All right, so like we said last week, Friday, we've got two sections in this unit from the old textbook, 4.5 and 4.7. We did 4.5 last week, Friday. Okay, that was all of 4.5. Last week, Friday was graphing the other four trig functions. Okay. Then today we're going to start 4.7, and we're going to do 4.7 the rest of this week. And yes, we will be testing on 4.5 and 4.7. So graphing cotangent, tangent, secant, and cosecant, and then all of the inverses, we will be testing on that next week, Tuesday. Yes, we are fully aware that next week, Tuesday, is the pre-ACT. Okay, we'll just adjust. Okay, we'll just adjust that. But that we're going to take a test next week, Tuesday, in class on 4.5 and 4.7. Okay. So you are in your notes today, and we will be doing inverse sine and cosine today. Tomorrow we'll hit up inverse tangent, and we'll start composition of functions. Thursday we'll do all kinds of compositions of functions, and Friday we'll review. Okay? So here we go. This is what your cotangent graph should have looked like. Most of you got that one. You were good to go on that one. This is what your secant graph should have looked like. Some of us had some issues with figuring out those points, and that's fine. Okay? But just know that, so those four graphs, of those four graphs, you might have to graph two of them on the test next week, Tuesday. Okay? So you got to remember how to graph them. Make it easy. Do your fractional logic. Fractions equal to 0, fractions equal to undefined, fractions equal to 1, fractions equal to -1. Okay? Okay? Today, we're going to talk inverse functions. Okay? We're going to talk some inverse functions. Now, true Mathematica will tell you that an inverse function, if you have two functions, f and g, that f of g of x, so you put g of x into f of x, that's going to have to equal g of f of x. Put f of x into g of x, and both of those will simplify down to just being x. Okay? That's true proving of an inverse, and you've got to prove both of them if you're proving an inverse. F of g of x has to equal x, g of f of x has to equal x. Okay? That's true proving of math. In more common terms, okay, to find the inverse of a function, you switch x and y. Okay? So if my function is y equals 3x, if I'm going to switch x and y, that's going to become x equals 3y. Then you solve for y. Well, if I'm solving this one for y, then I get y equals x over 3. And these two functions, 3x and x over 3, are inverses. Okay? To prove it, if I did f of g of x, so if I put the inverse into the function, I would have 3 times x over 3. That's just going to be x. That's me putting right into left. Me putting left into right would be 3x over 3. That's equal to x. So both f of g of x and g of f of x are equal to x. So therefore, they are inverses. Okay? Let's get a little more complicated function. Y equals x plus 7. If I switch x and y, I get x equals y plus 7. I get y equals x minus 7. Right into left, that would be x minus 7, then plus 7 is x. Left into right, that'd be x plus 7, then minus 7, gets me x, and it's solved. Or I should say it's proven. Get a little more complicated function. Y equals x squared. X equals y squared. So then y would equal the square root of x. Left into right be the square root of x squared, which is just x. Right into left, it would be the square root of x, then squared, which is just x. Proven to be inverses. Where we're going with this is we're going into trigonometry. So we've got y equals the sine of x. So this would be my original function. What can you tell me about the domain of y equals sine of x? It is all real numbers. What can you tell me about the range of my original function? -1 to +1, inclusive. Right? So if x and y switch to create the inverse, I would look like that, correct? Which we would write then as y equals the inverse sine of x. And this would be my inverse function. If x and y switch to create the inverse, domain is associated with x or with y. Domain is associated with x. Range is associated with y. So the domain and the range would also switch. So the domain over here on my inverse function would be -1 to +1. The range on my inverse function would be all real numbers. Let's go. Okay. Let's check out the graph here now. A normal sine graph starts in the middle, goes up, comes back down, and waves on through all the way. Agree with me on that? Okay. On a normal graph, we can plot some points. So, for instance, it goes through the origin. This point up here is the point pi over 2, comma, +1. This point right here is the point pi, comma, 0. 3 pi over 2, comma, -1. 2 pi, comma, 0. If we're going back the other way, negative pi over 2, comma, -1. Negative pi, comma, 0. And so on and so forth. Yes? That's it. We shelf those.
Yeah.
Mm-hmm.
I think this is all of it, though.
Okay. If to find the inverse, we switch the x and the y, which means we switch the domain and the range, which also means then we do what with our points? We switch the x and the y and our points too, right? Okay? So if I am graphing the inverse function of sine, sine goes through 0, 0. Yes? Well, that's going to stay 0, 0. Because if I flippity-floppity those, it's 0, 0 on the left, 0 on the right, becomes 0 on the left, 0 on the right. Pi then went through pi over 2, comma, +1. Well, that would become the point 1, comma, pi over 2. Then it went through the point pi, comma, 0, which would become the point 0, comma, pi. Then it went through the point 3 pi over 2, comma, -1, which would become the point -1, comma, 3 pi over 2. 2 pi, comma, 0 becomes 0, comma, 2 pi. Negative pi over 2, comma, -1 becomes -1, comma, negative pi over 2. And so on and so forth. So that our graph of our inverse function looks like that. Where again, the domain is from -1 to +1. And the range is all real numbers. What's the problem with the inverse sine graph?
It doesn't fit the below vertical line test.
So it's not a function, right? Yeah. So we could have multiple answers on multiple, or we'd have multiple outputs for the same input. Okay? So it doesn't work. So we have to restrict it. Okay? And how we go about restricting it is, well, first off, let's talk a little bit about the notation. So the notation for inverse sine is the way that you've been seeing it forever. Or we're going to add one today. Arc sine. Those both mean the same thing. And just like when you were in geometry and you started using them, these are used to find angles. Regular sine, normal sine, if you will, we input an angle into it, we get out a real number. Inverse sine, we input a real number, we get out an angle.
So, when we start using the calculators, will using either of these get the same answer?
Yep.
Or do we have to use the other one?
I don't think that even the ones right behind you, I don't think they have arc sine without having to actually like go find it and dig it out. Yeah. Mm-hmm. Yeah. Yeah. So then where can we find the answers for those? But yes, handwritten, yeah. Handwritten, they mean the exact same thing. Yeah. So they're interchangeable. Okay. Handwritten, where do I find my answers? Well, I'm going to restrict my arc sine to one chunk, one part of that wave. And that wave needs to go from -1 to +1. But then it would go from -π/2 all the way up to π/2, just where it is on the part. Okay? So the inverse sine, or the arc sine, y equals inverse sine of x, or y equals arc sine of x, still would have a domain here of -1 to +1. That's what I'm putting in. But my range now is going to be restricted from -π/2 to +π/2. That will give us all of the answers that we can get from that. Okay? Here's the tricky part of that. You are looking at the right side of the unit circle. And only the right side of the unit circle. So if I see arc sine of 1/2 or inverse sine of 1/2, those both mean the exact same thing. So if I see that in my brain, I am saying to myself, where on the right half does sine, is sine x or y on the unit circle? It's y. Does y equal 1/2? So I come over here to the right side of the unit circle, and I'm only looking at my y values until I find 1/2, and that happens at pi over 6. Inverse sine or arc sine of -1/2, I'm saying to myself, where on the right half of the unit circle is sine or y equal to -1/2? And where is that? No. What do you got? Exactly. It's at -pi over 6. You want to say here pi over 6. Because that's what it is. On the unit circle, I'm looking at 17 of them around the room right now. On the unit circle, it says that on the right half of the unit circle, sine is -1/2 at 11 pi over 6. Okay? However, because of our restriction down here, that the range has to be between -pi over 2 and +pi over 2, then therefore 11 pi over 6 doesn't fall in that range. So I have to adjust it, and I'm going to say instead of 11 pi over 6, we say -pi over 6. Okay? You try now these next 4. Right side, unit circle, sine, √3 over 2. I got pi over 3. Yes? Right side, unit circle, sine 2. Can't ever happen. It's got to be between 1 and -1. Does not exist. Right side, 0. Sine is 0 at 0. Right side, -1. That would be -pi over 2. You want to say 3 pi over 2 there, but it's got to be in that range. Okay? Alrighty. Let's do the same for cosine. Okay? So cosine starts up. I don't like my right side. A little bit better. I'll let it slide. So we've got, it goes through the point 0, 1. Pi over 2, 0. Pi, -1. 3 pi over 2, 0. 2 pi, 1. -pi over 2, 0. negative pi, comma, negative 1. Negative 3 pi over 2, comma, 0. And negative 2 pi, comma 1. Agree with all those? Okay. So if I flippity-floppity those, 0, comma 1 becomes 1, comma 0. Pi over 2, comma 0 becomes 0, comma pi over 2. Pi, comma negative 1 becomes negative 1, comma pi. Three pi over 2, comma 0 becomes 0, comma 3 pi over 2. Oops, got that wrong. 2 pi, comma 1 becomes 1, comma 2 pi. Negative pi over 2, comma 0 becomes 0, comma negative pi over 2. Negative pi, comma 1, negative pi, comma negative 1 becomes negative 1, comma negative pi. And so on and so forth. So that oops, I missed. It's going to end up looking like that. It will also have a domain between negative 1 and positive 1. It will also have a range of all real numbers.
On a test, are we going to see both? Both?
Yep. Interchangeable. Okay. So we still have to restrict it. Go back to it. Because, again, just like sine, it's not a function. So we need to restrict it and to figure out where it is. So if I've got y equals inverse cosine of x, or y equals arc cosine of x, both interchangeable, I am now going to be looking. Ooh, that's bad. That was just bad. A little bit better. I'm going to be looking there. And so I'll go from negative 1 to positive 1. But I'll also go from 0 up to pi. I'm going to take that chunk of it. So my domain is still going to be -1 to +1, but my range now is going to be from 0 to pi, which is nice because that is the top half of the unit circle. And there's no negative angles, so it's just all straight up. Okay? What you see is what you get. You don't have to convert quadrant 4 angles into negative angles. Okay? Let's try some of these. So we've got inverse cosine of root 2 over 2. Could also be arc cosine of the square root 2 over 2. So my brain is saying, where now on the top half is x equal to the square root 2 over 2? Pi over 4? Agree? Okay. You try these 4. Top half, cosine equal to 0, x equal to 0. I get that at pi over 2. Yes? Top half, cosine equal to -1/2, 2 pi over 3. Top half, cosine equal to -1. That's at pi. Top half, cosine equal to negative square root 3 over 2, 5 pi over 6. Yes? Okay. This unit, we're going to try homework a little differently. I'm going to hand you out 2 sheets today. Instead of giving you a homework packet, we're going to make you create the packet as we go along. Okay? So that everybody then will have to staple on Tuesday of next week when they turn their homework in. Okay? All right? So you get 2 sheets today.